and your names are from A to Z. You have observed that in a class, your teacher stores your names in the form of a register which contains all of your names alphabetically. But why is this method of storing alphabetically used? Say that out of these 40 students, I have to find out the names of all those that start with the letter N. Had this order not been maintained, it would have been possible to still find out all the students whose names start with N, but it would have been difficult. Now consider that you are a school of 500 students, and I still have the same problem of finding all the students whose names start with N. Now this is a tedious job. However, if all of these students' names are arranged alphabetically from A to Z, it becomes quite easy to find all those names that start with N. This is why we store data in such a way that we can use it efficiently. Considering this example, let us go ahead and find out what exactly are data structures in algorithms. So the term data structures can be divided as data plus structure, where data can be any value or set of value. In the previous examples, we had a set of values that were set of names of all students. And structure, as per its literal meaning, is an arrangement of and relations between these data. In the previous case, alphabetically storing was a structure. So data may be organized in different ways. We can organize it alphabetically, numerically, ascending, descending, etc. in however many ways possible. And the logical or mathematical model of a particular organization of data is known as a data structure. In simpler terms, a data structure is a particular way of organizing data within a computer so that it can be used effectively. In the previous example, like we had to access all of those names that start with N. So organizing it alphabetically made it efficient for us to order and store all of those that start with N. Hence, the extraction of data becomes easy when you use a data structure. Moving on to classification of data. Now we know what data structure is. We also must know that there are a number of types of data structures. At level 1, these data structures can be divided as primitive and non-primitive data types. Primitive data structures are those that are defined by language. By saying defined by language, we mean that these are built in. We don't have to code or build all of these data structures in order to store them. The examples of which are integer, real, character, and boolean. However, non-primitive data structures are also known as derived data structure. Why derived? Because they are derived from primitive data structures. That is, primitive data structures combined form non-primitive data structures. Further, non-primitive data structures are also divided into two, linear and non-linear data structures, that shall be discussed in the upcoming lectures. Now that we know that there are multiple types of data structures and all data structures have different uses, but how do we decide that which data structure should we use in what kind of a problem? To answer this, we have two parameters. Firstly, that the model must be rich enough to mirror the actual relationships of the data in the real world. Actual relationships meaning that suppose there are two entities A and B and they are related by more than one relations. Say R1 relation and R2 relation. This can be like suppose that A is mother and child. So A is the mother of child and A can also be a mother of another child. So there can be multiple relations from one entity to other entities. So the data structure that we used must be efficient enough to mirror all these relationships. Secondly, that it should be simple enough that it can effectively process the data whenever necessary. Processing data means as per requirement we get the data that we have stored. Now that we have understood what data structures exactly are, let us dive into what an algorithm is. To understand algorithm, let us consider an example of preparing a lemonade. Say that you are supposed to prepare lemonade for 4 guests at your place tonight. What do? You firstly take 4 cups of water, after which you take 4 lemons and squeeze it, followed by 8 tablespoons of sugar, followed by 4 tablespoons of salt and black pepper, followed by ice. Serve it, after which your process comes to a stop. So what we just wrote was a flow chart, meaning a pictorial representation of the steps involved behind preparing a lemonade. Now that we write these steps in a formal language step-by-step procedure, we begin with start. We begin with taking 4 cups of water. Cut and squeeze 4 lemons. Add 8 tablespoons sugar. Mix it. Add 4 tablespoons salt. Add black pepper and ice. Serve it, and finally stop. So what we just wrote was a step-by-step procedure to prepare lemonade. This is what is known as an algorithm. So moving on to definition of an algorithm, any well-defined computational procedure that takes an input in the form of some values or set of values and produces an output in the form of some value or a set of values is known as an output. So input in our previous example was water, sugar, salt, lemon, pepper powder, ice, right? And what we made the output as was a lemonade. Applying this real life example to a computational procedure is what is called an algorithm. So formally defining, an algorithm is a sequence of computational steps that transform the input to the output. Now that we know what an algorithm is, how do we decide whether the algorithm that we have written is correct or not? And what are the probable characteristics of an algorithm? So an algorithm will be correct only if it halts at the correct output. And that correct output should be for every input instance. Considering again the lemonade example, if the lemonade tastes good, then the procedure that we have followed is correct and our algorithm is correct. Now, taking another computational example, let us see that you are engaged into competitive programming, wherein you have a given problem and you design some probable solution which has an algorithm involved in it, right? So you write an algorithm and you check. Now what the computer does, that it has a total of say 10 test cases. If your algorithm gives the correct output for all those 10 test cases, only then you are eligible to submit and you are marked correct for that problem. So an algorithm will be correct only for every input instance it halts with the correct output. If not, then it is an incorrect algorithm. Moving on to characteristics of an algorithm, they have a number of solutions. Number of solutions meaning, let us consider a sorting problem. If you are aware of sorting problems, there are a number of sorts such as selection sort, merge sort, quick sort, insertion sort, etc. And all work differently, but they solve the same problem of sorting. Now finding the best algorithm out of these is a tough task, because then you have to analyze all of these, calculate the performance time, calculate the space complexity, time complexity, etc. And only then you are able to find which is the best algorithm. But the problem of sorting can be solved by a multiple of algorithms. Moving on, that they have a practical application. Practical application meaning that a given problem should have some use in a real life scenario. So suppose you consider a shortest path problem, wherein you have to find the shortest path between any two cities, say A and B, and there are multiple paths possible. There are intermediate cities which you have to travel to finally reach to B. This theoretical problem is actually applied in a flight booking system. Say that you are supposed to travel from Punjab to Chennai. There are multiple flights, but there are no direct flights. You have to at least halt between 3 stations, 1, 2, 3. The costs of which are different. You can go from Punjab directly to 2, then 2 to 4, and then say to Chennai. And there are a number of ways to reach from Punjab to Chennai. Now, using this shortest path problem, you can actually find out a perfect way wherein you will minimize your cost as well as minimize the time to reach from Punjab to Chennai. So, any algorithm that we have must have a practical application. Moving on, today we have extremely fast computers. We are heading towards supercomputers. The computational power has increased exponentially over the past decade. So, what is the importance of algorithms? As in, why should we consider about time or space? Because all of these days are, with advancing technology, we have very fast computers, as well as space costs almost nothing to us. But there are certain reasons why we should use algorithms and why we should have detailed knowledge about algorithms. Firstly is the fact that knowledge of a number of methods makes it easier to choose the best. Only if you know all the algorithms of sorting, only then will you be able to find out which is the best method for you to use. Second is the fact that it is always good to understand the actual working of a component of software. Say that you're designing a software and you have to explain to your fellow developers. How do you do that? By understanding each and every algorithm that is involved behind it, right? So it is very important for your as well as your colleagues' knowledge to know what you are building exactly and how does it work at its core. Thirdly is the cost of memory. So even if space is now available, it is almost inexpensive, but it is not free yet. So computing time as well as space and memory is a bounded resource. However much we try, it cannot be infinite. So we must use these resources wisely, and algorithms that are efficient in terms of time and space shall definitely help us do that. And algorithmic knowledge, core algorithmic knowledge, is what distinguishes an average programmer from an advanced programmer. And by an advanced programmer, I don't mean that taking up advanced courses and knowing different technologies, but an advanced programmer is someone who can apply his knowledge to real life. And that is what we engineers are here for. We have to apply our knowledges to real life in order to solve real world problems. So I hope that you understand what algorithms are, what data structures are, and now I hope that you're ready to dive details